All right, so we finally get to the new stuff. We're going to talk about covalent bonds and ionic bonds. So, if an atom's neutral, you'll remember that it has equal numbers of protons and electrons, so the positives cancel out the negatives and the overall charge is neutral. So that's fine, but the question is that what makes an atom stable? So they can be neutral and stable, or neutral or stable, or whatever. So what is it that makes them stable? Some of you guys know. Think about it. It has to have a filled outer valence shell. So it has to have filled S&P orbitals in its outermost energy level. So that means how many for most of them? 8. You got it. And atoms really, really want to be stable. They're not quite so concerned about being neutral. Stable is way more important than being neutral. So they're going to do whatever they can to fill that outer energy level. In order to do that, though, they need to react with some other atom that also wants to become stable. And that's what happens when a chemical reaction occurs, is that in an attempt to become stable, these atoms exchange electrons or share electrons, and they get their outer energy level filled, and they're happy. So that's what they want to do. They want to fill their outer S and Ps. So they can do one of three things in order to do this. They can share valence electrons with other atoms. Those are the most friendly atoms, the sharing ones. No. They can give valence electrons away to other atoms to get rid of some of the ones they have, or they can take valence electrons from other atoms. So this process of giving electrons, taking electrons, or sharing electrons are what cause chemical bonds to form in the first place. So let's talk about the sharing ones first. If atoms share electrons, the sharing has to be equal. There is no exception to this rule. Okay, if I share 1 with you, you have to share 1 back with me. If I share 2 with you, you have to share 2 back with me. So the sharing has to be equal. If it's not equal, then this doesn't happen, this covalent bonding. During the sharing, each of the atoms involved gets a filled outer energy level with the S&P orbitals, and it's called covalent, co meaning together. And so a covalent bond is formed when 2 or more atoms become stable by sharing valence electrons. So let's take a look at chlorine. So we have 2 chlorine atoms, each of whom have 7 valence electrons. How many more do they each need in order to have a filled outer energy level? Hopefully you said 1. So they each need 1. Is there a way for them to share so they both end up with 8? Indeed, there is. Each atom, remember earlier we talked about the fact that the sharing has to be equal. They each are going to share 1 with each other. So if you look at the diagram, you can see they started out separately, but when they got close enough, one of the electrons from one of the chlorines spent some time around the other, and the one from the other chlorine spent some time around its other. So that's where they share. The electrons spin around both nuclei of those chlorine atoms. I'm a big fan of the Venn diagram. So what I do is I circle the 8 that are making one atom happy, and I circle the 8 that are making the other atom happy, and where those 2 circles overlap, so there's the Venn diagram, you get this thing called a shared pair. And that's what makes the bond covalent. So you don't have to draw the Venn diagram, but I think it helps to identify where that shared pair is, and that in fact this is a covalent bond. Just to keep in mind, the electrons move so fast. Remember, and that's that whole probability about being in an electron cloud, that for all intents and purposes, that those electrons are around one nucleus, and at the same time they're around another nucleus. So they're basically their 2 electron clouds kind of overlap and merge a bit. It's kind of cool. In terms of writing chemical equations, we have one chlorine plus another chlorine, and it yields not two separate chlorines, but two chlorine atoms bonded together. And that's where that 2 comes from, because there are two separate atoms that are now bonded together. Atoms, when they share, they don't have to share only one. As long as the sharing's equal, they can actually share more than one. And then they would have more than one shared pair. So here are 2 atoms of oxygen, and they combine to form oxygen gas, which is O2. And the way they do it is by sharing 2 electrons apiece, because they each start with 6. They both need 2 in order to become stable, and so they do this. They have it's called a double bond, and in a double bond you have 2 shared pairs. And you can again see that with the Venn diagram and the shared pairs where the overlapping occurs. And so we went over this already, but an atom of oxygen plus another atom of oxygen, when they bond, forms a molecule of O2. And this 2 as a subscript means that 2 atoms of oxygen are bonded together. So now think about this. We looked at a single bond. Now we have a double bond. So take a wild guess what a triple bond would look like. You got it. There would be 3 shared pairs. Atoms can also create shared pairs with more than one other atom. So it's not always just one atom sharing with one other atom. You can have one atom sharing with 3 different other atoms. Or in this case, 4. So we have this compound, CH4. We have a carbon, and we have 4 hydrogens. Well, how many more does carbon need to be full? Right, it needs 4 more. Now think about this. How many more does hydrogen need to have a full outer energy level? Not 9. Not 7. It actually only needs 1 more. Because remember, hydrogen only has 1 energy level. That 1 energy level only has 1 s orbital, and it can only hold 2 electrons. So, if carbon needs 4, and each of these hydrogens only need 1, and there are 4 of them, let's set it up like this. And again, you can do the Venn diagrams to show the shared pair between the hydrogen and the carbon. The chemical equation for this one would be a carbon plus 4 hydrogens yields a carbon and 4 hydrogens. The 4 becomes this subscript saying that these are all now chemically bonded together, whereas the way they're shown over here, they're all separate atoms. So at the beginning, they're all separate, then there's a chemical reaction that occurs, and then they're all bonded together with covalent bonds. All right, so here's the deal. Thinking back to your coloring sheet, your periodic table at a glance, all of the elements that we have talked about in this video have all been nonmetals. So here's a rule to follow when trying to determine whether or not atoms would form ionic or covalent bonds. If they're all nonmetals, then they're going to form a covalent bond. That's the rule to follow. And so there it is, and next we'll talk about ionic bonds.